Hello, I'm Emmanuel. Welcome back to Economics. In this video, we'll be continuing our discussion on correlation. From previous videos, we've learned about the idea of correlation coefficients, and we made mention of the fact that correlation looks at the degree of association between two variables. And if you remember very well, we've been emphasizing the fact that the Pearson correlation coefficient, which we looked at the simple and also looked at the partial when you try to hold for and that variable, you try to hold it constant. We mentioned the fact that those correlation coefficients look at the linear association between those two variables. But here now we are introducing a new measure of the correlation coefficient, which is Spearman rank correlation coefficient. And this doesn't just look at the linear association between the two variables. It's actually a measure of the monotonic relationship. So you're not defining a particular format. You recall on your scattergram, let's say a variable x and a variable y. When you have, say, something like this, easily you can pick a linear relationship. That's your Pearson correlation coefficient will do for you very fine. I remember the formula we discussed earlier regarding Pearson. It worked beautifully well. But when you are having a relationship that is non-linear but is monotonic, something like this, okay, so they kind of follow closely. If you try to use your Pearson, you will get something kind of linear. But the Pearson, the Spearman rank correlation corrects that deficiency, and so that's an advantage of the Spearman rank. What other advantage can be derived by using the Spearman rank? The other advantage is that Spearman rank is useful when observing qualitative data. Data that you can't attach specific numeric measure to it, but you can rank. Let's say you give if a questionnaire was given to students to fill in something and they're saying strongly agree, strongly disagree, agree, not sure, something like that. So there's some sort of ordering between these variables. You can rank them, say give 1 to this, give 2 to this. With that, you'll be able to use your Spearman rank correlation coefficient. So unlike the Pearson correlation coefficient that works with two numeric variables, the Spearman ranks you can use it to work with numeric variables and rank them. As you see in this hypothetical case, we use the Spearman rank for this, and you can also use it where you don't even have numeric descriptions, where you just have, say, preference for people ranking utility and preferring bread to butter or something like that. So that's the idea. So we'll be looking at a practical example. Here we have a list of students, their observations. So students can just be like Ade, Bola, whatever. So just the names of the students. I just use A just to save space. And we're looking at their performance in two courses, Microeconomics and Macroeconomics. So for student A, he had 85, let's say over 100 in micro and 86 in macro. B had this score, C had this score. What is the purpose of this? Now, we want to look at the relationship between a student's score in microeconomics and the score in macro. We want to see if they closely follow. So can you just say a student is doing very well in macro, probably will do similarly well in micro, or is there an inverse relationship, something like that? So at the end of this class, we'll be able to bring that out using this formula. And this is the formula actually outlined for the Spearman rank correlation coefficient. Very easy formula. RS, still your normal correlation coefficient that ranges between 1 and 1. Remember we said when it's plus 1, it is a perfect positive relationship. When it's minus 1, it's a perfect negative relationship. So all the points fall like on a line, like they follow each other closely. And the further it is from 1 in terms of absolute value, the closer it is to 0, the weaker the relationship. So the Spearman correlation coefficient also ranges between -1 and +1. And this D here is the difference between the ranks of each observation. We'll be ranking these variables. And just to mention before we do that, the ranks could be done in either ascending or descending order, and n is the number of observations. So let's work out this example now. Okay, so we've been given the individual scores of the students in microeconomics and macro, and the next thing we are going to do now is rank them. Recall this is the formula: 1 minus 6 summation d squared. And I mentioned earlier that d is the difference between the two ranks. So we are going to rank the students perform their scores in microeconomics. We'll rank their scores in macroeconomics too. Then we'll take the difference. That will give us this d, and we're able to get this squared and then sum. And n is the number of observation, the number of students. We have 10 students. So to get this, to get the Spearman rank correlation coefficient, we need this squared summation, this squared. We already have n and we can get n squared. So the first thing is to rank their performance. This is the ranking for their based on their microeconomic scores. Here I use descending order. I said you could rank in either ascending or descending. So the highest score takes like first position if you look at it that way. If you look at the scores, the highest here is 85. So student A ranked best in microeconomics. Then next down you have 83. So student I second. Then with that you can look at after 83, where is the next? Okay, 79, 3, and you rank on and on till you get to the lowest score, which rank 10. Same thing for microeconomics. The highest score here is 90. So this is 1, then followed by 88. This is 2, on and on. So we do that. In a case where two students have the same score, let's assume this person had 88 and this student A had 88 and student B also had 88. Now, you know, the rank here based on this guy took first here, so somebody was supposed to take second, someone was supposed to take third, right? But they had the same score, so you can't say both of them are second. Both of them will take the second rank and skip the third. No, you won't do that. So you just assume somebody takes second, someone takes third, and you find the mean. So you will say something like 2 plus 3 divided by 2, and that rank is 2.5. So each of them will take the rank 2.5. I don't know if that's clear. So that's the idea in case of a tie. But here we don't have a tie, so we don't need that. So our ranks are all in discrete numbers, and so we can move with this formula. If there's a tie, this formula won't work. We'll make use of the normal Pearson correlation coefficients we've done. The Spearman and Pearson, they are essentially the same. The Spearman is just a non-parametric is a non-parametric version of the Pearson correlation coefficient. It doesn't assume a linear relationship, so it eliminates that. And if you have decimals in your ranks where you're taking means, then you won't be able to use the Spearman. You won't be able to use this formula. You just use the normal formula of their covariance divided by the product of their standard deviation. So now that we've ranked them, we'll take the difference, and difference is simply 1 minus 3, 2 minus 2, 3 minus 2, 1, 7 minus 8 minus 1, on and on. Then we square this difference, the difference between the paired ranks. So this 4 minus 2 times minus 2 is 4, 1 squared is 1, on and on, and we sum to get the summation of the square differences. So with that, we already have the summation of square differences as 26. We have the number of observations as 10. Easily we can calculate our Spearman rank correlation coefficients. So moving on to solving for the correlation coefficients, we have the formula here and we've completed the table. The summation d squared is given as 26 and n is actually 10, the number of students, the number of observations. So we have A, B, C, D, E, F, G, H, I, J. So 10 students, and then we just insert the values and solve. So the Spearman rank correlation coefficient is 1 minus 6 times summation d squared, 6 times 26 So we have that divided by 10, n into bracket 10 squared minus 1. And so this will be 1 minus 156 divided by 10 times 100. 10 squared is 100, so 100 minus 1 is 99. So this is 1 minus 156 over 990. 1 minus 0.1576, and our Spearman correlation coefficient is 0.8424. It's positive. So you see that student scores in microeconomics sort of in a way move with the scores in microeconomics. It's positive and relatively strong. From our ranks, we can see it for student A was the first in micro, third in macro. For student I was second in micro, first in macro. Okay, and for someone like in now, ninth in macro, ninth in micro, micro and micro. So they sort of move together, and so that's about the explanation. It shows sort of strong positive relationship. Now, not linear, monotonic relationship. If it's a PSM, we specify explicitly that by looking at the linear association. So that's all for the Spearman correlation question, and that brings our discussion on correlation to a close. In future videos, we'll be considering regression. Thanks for staying with us, and thanks for watching. We look forward to having your questions, comments, likes, and as well as subscription on this channel. Thank you.
Hope you enjoyed the video you just saw. If you want more of our videos, please make sure you subscribe to the channel and click on the notification bell. Now, there is a way to enjoy to make the best of our YouTube channel, which is to go to the playlist section of every video or of every topic. So what you have to do is just type Economics on YouTube. When the page displays, make sure you subscribe. The bell button appears immediately, so you click on that bell button. Then go to the playlist section. So you're going to see videos, playlists, description, and all of that. So just go to the playlist section, and whatever topic you are looking for, look for the playlist and click on the video. Now, our playlists have the classes arranged in a very chronological manner. So if you want to see a class on ISLM, so it starts from the beginning, the simple ones to the difficult to the complex ones. So if you want to see a video on, let's say, elasticity of demand, so you start from what is price elasticity, so from there then to the basic ones, and on and on. So I'm just telling you that in case you really want to make the basis of this YouTube channel. And there's also one thing that I want to add, which is that our YouTube classes may not be enough for you. You may want a regular interaction with the tutors and all of that. So what you just have to do is to check the description of the video. You are going to find a WhatsApp link. So, but before you do that, I really have to tell you that clicking that link is going to lead you to one of our schools. It's going to lead to some of our schools. So we have MOGE School of Economics on WhatsApp, and we make use of our YouTube channel to run the groups. So the classes are paid for, so you're meant to pay for them. So to join our Econometrics school, so that is 2,500 naira per month, and to join our Microeconomics or Macroeconomics schools, so that is 2,000 naira per month. We also have we don't have classes, or we don't have schools of mathematical economics, because microeconomics has its mathematical aspects as well as macroeconomics. So the mathematical aspect of macroeconomics is treated in the macroeconomics school, and the mathematical aspect of microeconomics is treated with the microeconomics school as well. So I'll see you next time. Thank you very much for watching.